this product review, we're going to look at the Sunsync inverters. The Sunsync inverter has become extremely popular among solar installers as it is proven to overcome high electricity bills as well as power outages. In this video, I'm going to show you what a Sunsync inverter is and why it's become so popular. What is a Sunsync inverter? A Sunsync inverter is best described as a bidirectional solar inverter charger. In some circles, this inverter is also known as a hybrid inverter. But the term hybrid inverter is very confusing as there are several different definitions for a hybrid inverter. Now, when a client requests a hybrid inverter, it is best to ask which features are they looking for in that inverter. To best understand a Sunsync inverter, let's first look at the electricity demands of a house. Now, the items that consume electricity in a house would first be lights. There may be a TV or even TVs. There may be a router. There may be audiovisual or satellite TV equipment. There may be computer equipment, a fridge, a washing machine, a dishwasher, an ironing machine, vacuum cleaner, a geyser, a kettle, an electric stove, an aircon, a fan, or maybe even several fans, and some power tools. Now, the stove and the geyser are high consuming items, and instead of putting these things on an inverter system, it might be a better idea to rather spend the money and invest in a gas stove and a solar geyser, or even a solar geyser retrofit. Now, when you've replaced your stove with a gas stove, you may as well throw away your kettle, as the kettle is also a high consuming electrical appliance. And a better investment would be to simply use a gas kettle that will work on the stovetop. Now we can eliminate the stove, the kettle and the geyser from the appliances that consume electricity in the house. Now, if we are to combine all these electrical equipment under one category, it will mean that we need a large battery bank or even several battery banks to run all this equipment at once. And that would simply be bad advice. The more efficient way is to look at the critical load and non-critical load. So let's first look at critical load. The critical load would be appliances that you would use mostly at night. Now, those appliances would be your lights, the TV, the audio equipment and Wi-Fi router, the computer, the fridge, the fans, and the air conditioner. Now, there's some of this equipment, like the fridge, that you would use during the day as well as at night. But bear with me, this will make sense. All this equipment will be classified as your critical load. Now, the power tools, the dishwasher, the washing machine, the vacuum cleaner, and the ironing machine could be classified as non-critical load. Now, by changing the consuming habits, all the non-critical load could be instructed to only be used during the day. Now, the critical and the non-critical load will be split in the DB board. Now, an additional earth leakage as well as a neutral bar needs to be installed for the critical load. The non-critical load can run on the existing earth leakage. Once that rewiring has been done, you'll have a clear critical and non-critical load in the DB board. Now, a Sunsync inverter would operate with solar panels and batteries. The Sunsync inverter has a built-in charge controller, so the panels will be directly connected to the inverter. The inverter will then be connected to the batteries. Now, the first priority for the solar panels is to provide charge to the batteries, independent from the grid. The output of the inverter will be connected to the critical load. So at night, the batteries will provide power to the critical load. Now the non-critical load will be connected via the grid. And the Sunsync inverter will also have a grid connection. Now, if the system was correctly sized, you should have enough solar panels to provide power to the non-critical load, the batteries, and the critical load. Now the sun will provide power via the solar panels to charge the batteries, run your critical load during the day, as well as the non-critical load. Once the batteries are fully charged, the solar panels will still provide power to the critical load as well as the non-critical load during the day. Now let's say there's a scenario where your non-critical load for a certain day is not as high as what it normally is. Now the Sunsync inverter will push that additional power back into the grid. The problem is this may not be allowed by certain municipalities, but there is an easy solution in the form of a CT. The CT can be connected to the input line of the inverter or the input line from the grid. This CT will be communicating to the Sunsync inverter. If there is additional power produced by the solar panels that is not being consumed by the non-critical load, the CT will simply prevent that power from being fed back into the grid. If there is appliance in the non-critical load that is then switched on, the Sunsync inverter will automatically direct that power to the non-critical load and not draw that power from the grid. Now in a cloudy or rainy day, where the solar panels are not producing the amount of power required to charge the batteries, run the critical load and the non-critical load, that power can be used from the grid to charge the batteries, run your non-critical load as well as the critical load. This option would only be required when there's rainy or cloudy days. Now when there's a power failure due to load shedding, maintenance or cable theft, the solar panels will still produce enough power to charge the batteries and run the critical load. The non-critical load will have no power during power failure, as the inverter's feedback function will not be enabled unless there's power coming from the grid. The grid would only be needed as a backup during rainy or cloudy days. So let's take a closer look at the Sunsync inverter. These units are available in 5 kilowatt and 8 kilowatt. It has an integrated bidirectional function. It's got a built-in multi-stage battery charger. The battery charger is able to charge AGM or lithium phosphate batteries. The battery charger can be configured to the correct charging current and charging voltage. This inverter is able to operate with or without batteries. The Sunsync inverter has two integrated MPPT charge controllers. The MPPT charge controllers has a high input voltage. The inverters are able to be paralleled in single phase or in three phase. The inverter is programmable with multiple operation modes. The settings, operation and status can be viewed on the display or monitored via the integrated Wi-Fi dongle. Now the benefits for having a Sunsync inverter installed on a solar system. It gives the clients the ability to charge the batteries from the grid or with solar. The Sunsync inverter has the ability to run critical load from solar, batteries or the grid. The inverter has the ability to run non-critical loads from solar or the grid. Please remember that non-critical load will only run from solar during the day if the grid is present. If there is a power failure, the non-critical load will not have power, only the critical load will have power. The inverter has the ability to enable the feedback function or disable the feedback function. This inverter has the ability to create significant savings on the monthly electricity costs. The Sunsync inverter certainly overcomes all the challenges when it comes to high electricity costs and power outages. However, for this inverter to work optimally, the correct design needs to be done. Please ensure that the design was done correctly before installing the Sunsync inverter. This video was brought to you by Voltex, your electrical connection. For more information about the products that's been discussed here, please visit one of their many branches countrywide. Or visit their website at www.voltex.co.za.